it's a bit loud. Let's look. Here we go. Hello everyone, thank you for joining the Java Native Interface presentation. My name is Ufimtsev. My contact information is here. So I am a software engineer at Red Hat. My main work is I work on SWT on the Linux side of things. I normally give this presentation at a university and I have 2 hours to do so. Now I kind of need to squish things into half an hour. So I'll be going through pretty quickly. I'll try to squish in a demo if I have time. So in general, this presentation sort of assumes that you know C and you know Java, and you sort of have at least an understanding of how to compile a library in C. If you don't know, it's good to read up on those topics. I used Linux and GTK as an example, but GNI is a cross-platform technology that works in Windows or any Java-supported platform. So just to give you an idea of where GNI is compared to everything else sort of in the world, GNI is part of the JVM itself. It's been part of Java pretty much since it was released. In the meantime, there's been a lot of frameworks that were built on top of GNI, like GNA and SWT and a whole bunch of others. GNI is useful if you want to implement higher level frameworks, if you have code that is performance critical, because GNA is quite nice to use, the framework on top, but it has performance troubles in certain scenarios. And another use case for GNI is if you have a lot of C code and just need to spawn your own JVM, for instance, that's another use case as well. With that said, use GNI at your own risk, because it's very easy to make mistakes. So usually I like to engage my audience by asking a question. Now I won't give you the answer right away, I'll get you guys to think about it and we'll come back to it at the end of the lecture. But Java has garbage collection built in, whereas C doesn't. Now what happens if you allocate something in C and pass it to Java? Will Java collect the memory for you, or do you need to free it up manually? Now my hope is at the end of the lecture everybody will understand, but for now can I just see a show of hands who thinks they know the answer? Okay, that's more than a university crowd. Okay, great resources to get started is the Java Native Interface book. It's a bit old, but nothing has changed. It took me about 2 weeks to learn, but you really get a good feel for what GNI is about. And if you just want to get started real quick, there's a bunch of blog posts. One of them is mine. Some are Linux, some are Windows specific. So we'll just kind of briefly touch on every part of GNI, how to call C from Java and how to call Java from C, how to mirror structs. We'll go over a use case and I'll show you how to do the cross-language debugging. So in general, GNI allows Java to call C and C to call back Java. C can also spawn a JVM instance and hook into Java and access any part of it. For example, C can access private members of any struct. The great thing about GNI is that it allows you to access any part of the OS functionality that you normally cannot with Java. You can also use OS-specific libraries like interact with OpenGL and a bunch of other cool things. That's essentially what SWT does. We kind of interact with the operating system quite natively. It can be used if you care a lot about performance, but you need to be careful because you can actually introduce performance overheads. And GNI is great if you need to call other languages from from Java. However, there are a bunch of pitfalls, and I have multiple slides on pitfalls. As soon as you start using GNI, you kind of tie yourself down to platforms. So instead of having one build server, you will now have multiple build servers for every platform that you support. A small mistake in C can cause the whole thing to come down. Like a segfault is very easy to come around. And the memory management model is a bit tricky because you have to deal with multiple different types of memory management, which can easily introduce memory leaks. Debugging the whole thing is not straightforward. You need to use 2 debuggers and you can't kind of go from one to the other. You kind of need to set breakpoints on both sides of the wall. In the past, there was no optimization for inlined for JVM calls, but with the new Open J9 JVM, I think, now inlines them, so that kind of improved things a bit on that. part. Now, when you use GNI, you kind of have to be careful because sometimes it can copy in big chunks of the array, of a Java array, for example, into C, and that can be more expensive than, for example, doing it in Java itself. Another thing that especially newcomers I see sometimes make is that they start using Java objects in C directly. Now, you cannot do that because Java objects differ in their implementation from each JVM. Some JVMs, for instance, they keep their string formatted in different places. So one string can be in different parts of memory, whereas in C it's usually a contiguous set of memory. So one thing a primitive can be used, it will be copied from Java to C, but anytime you deal with a reference, an object, you need to handle it with great care. And another thing, internally, the JVM uses a different type of UTF. It uses a UTF that uses only 3 bytes instead of the standard 4 bytes. So things like emojis are lost in translation. To get around that, you will have to convert strings yourself manually in Java and then pass the pointer back to C. So how do we glue all that together? In general, you start off in Java, and any method that has a native tag on it is marked for sort of compilation to C. In C, you start off with a header, and you implement your own method. And then when you start the Java application, you load the library that you will have compiled from your custom code. And I'll step through each section bit by bit. So first of all, the code generation. In Java, you tag things with the native keyword. Next, you run the Java C compiler, and it automatically reads the classes and generates these C function declarations. You then implement these declarations and do something useful with them. So to understand these declarations, Java is appended automatically. Hello GNI is your class name that is taken from your Java class, and then the method name follows. The arguments are created for you automatically. So the next thing will be to take your code and compile it into a Java native, into a native library. On Linux, it's lib.so. On Windows, you will see a .dll. To do so, you basically tell GCC that you would like to compile position independent code, and you pass along, you include the GNI headers. Now, those GNI headers are quite useful. They're part of your JVM installation, and they're basically the API to GNI. Whenever I work on GNI, I have that file open to see which methods I need to call. So the next task is once you run your Java application, you need to tell it where it can find that native glue code that you compiled. You have to do so even if the SO is in the same folder as your Java file. And to do so, you specify the LD library path. So let's run through a quick example on how that whole thing works. Here's a basic example. Afterwards, if you have interest, you can download and tinker around with it. So the first step is to take your Java file and compile it into a class file using the standard Java compilation mechanisms. Then you use Java C to compile your Java class into a header, which will generate those declarations. You yourself then copy that statement from the header into your file and implement it. Then you compile your code into a library, and away you go. You just specify the LD library path where you find where the SO file is located, and you launch Java with your application, and that's it. If you want to run from within Eclipse, you need to specify the library path as a VM argument. And just from my personal experience, users, they start to add C code all over their Java classes. That makes it a bit difficult to deal with the compilation and figuring out how many of those SOs you have. So a good practice is to put all of your native code into one class. That's what we do in SWT as well, and just compile that and just generate one library. So let's look at GNI internals. Do you guys still remember the question at the beginning? Keep thinking about it. So when we look at these methods that are generated, the first thing you might come across is this GNI env, which is basically the a pointer to the thread from which you can extract, get pointers to relevant GNI methods. And the other ones are just Java objects, for example, a string or a class. There's two types of pointers that are quite important that you should kind of know. The first one is the Java VM pointer, which you might generate at the start of your application, which is a pointer to anything in the JVM. And the second one is passed in the in the function from Java to C, the GNI environment, which is just a pointer to the current thread. It's important not to mix those two up. So one thing in C is that if you call a Java method from C, you need to check exceptions manually. Like C doesn't have any notion of exceptions. However, GNI provides you with some tools to help you along. If you do some calls, you can specify a parameter, and if you make some calls where you didn't check the exceptions manually, then they can throw some warnings into the console. And there's two types. The newer one is exception check, which just provides a true or false if an exception occurs. And the more older construct is exception occurred, which you can use to get more details about an exception. And now the interesting thing is that there's three types of Java references in C. And local reference, okay, that's like local to the function. And global reference is okay, that's global, like a global pointer everywhere. But what is a weak global reference? It's like, what the heck is that? And basically, if you'd like Java to manage, if you create a Java object in C, but you would like Java to handle the memory garbage collection for you, you create a Java object with a weak global reference. It's commonly used to sort of cache Java objects as you work with them. That way you don't have to worry about freeing them up. Hint, hint. Now, when it comes to calling a Java method, this is how it looks like. To explain, every method has a signature. For example, a Java method like this will have a signature like that. Basically, types get a letter assigned to them, and you need to specify it as the parameters and then followed by the return value. It's a bit counterintuitive because the return value is added at the end. In this case, the B is mapped to the B here, and then we have long, long. Now, when you actually call the Java method, you will specify the name of the method and the method's signature. It's okay for to create this signature yourself for primitive methods, but if you get into more complicated use cases, creating the method's signature is a bit tedious and hard. So you can actually get Java to do that for you. You can use Java P, although I think that might be replaced in the future. You just give it the compiled Java class, and it provides a method signature for you that you can pretty much copy and paste. This took me a little while to figure out. If we were to look at some actual code here, as you can see here, it loads the library. And as the C code executes, we want to try to call a method. So we get the method callback from C, and we specify the signature, and we call the method. This is usually how it looks like, not too fancy. This is an example of accessing, on the Java side, we have a member called str, and this is the C code that you would use to access that string. So this is one of the reasons I'm sort of warning people against GNI. It can do everything, but it is pretty verbose, because you manually have to first get the pointer to the class, the pointer to the instance, the pointer to the field, and then do a lot of memory management yourself. But everything can be done. So it can access, as you can see, the Field here is private, but GNI doesn't care. GNI has access to just about anything. So the next thing that often comes up is how do you map a Java structure, a class, to a C struct and vice versa with GNI? The answer is you don't. You have to write the wrapping code yourself manually. So you basically take each individual field and pass it to C, or inside C you have to manually pull everything out. Yep. So this gets very tedious very quickly as you have a lot of structs. So how do you deal with that situation? Option number one, you hire many software engineers, but that gets pretty tedious pretty quick as well. So another thing is you can use a framework. And modern frameworks, they do most of it for you. They cover most of the basic use cases. So I do recommend those. SWT was started a long time ago, and we needed some very custom functionality, so we ended up writing our own framework that does it for us. It basically looks at the Java class, like here as you can see at the top, and it generates the boilerplate mirroring code for us automatically. So how do we go about debugging all of this goodness? This is a quick diagram of how Eclipse works internally, and SWT is sort of this part over here, and this is where I spend most of my time. Personally, I use JDT and CDT to do all of that, but if you're savvy, you can just use pretty much any editor. So to actually demonstrate it, first you need to set a breakpoint in Java, wherever you want to debug. And I assume you already created all of the relevant structures. Then in your C code, you set a breakpoint for where you want GDB to stop. Then you launch your application. So here it stopped in the Java part. You just make a note of the PID. You use the option debug attached executable. You look for Java, and you connect GDB to the JVM that you just spawned. Initially, the C just pauses at thread join. You continue from here. And then you'll be back to Java. So now, if you click on continue, the GDB debugger will kick in and you're in C land. And it's sort of pretty much as simple as that. You just set the breakpoints in Java and C, and away you go. And you can do the same thing with the GDB in the command line. That's how I started. A useful tool is JPS, the Java process. It can print the PID of your JVM instead of having to look through PS exec. So how do you go about learning GNI if you do want to go ahead with using GNI in your application? So one thing about GNI is that it's not quite as hackable as maybe Python. It's sort of, when you start, none of it makes any sense. You sort of need to understand the whole thing before you can really use it efficiently. So I started off, I read the whole book. With that said, the last couple of chapters are pretty fancy, but chapters 1 to 10 are great. I would work my way through those. And as you learn, make sure try out snippets as you go along. They're pretty great. So just a word about the other frameworks. I already mentioned GNA, but there is a whole bunch of other ones, including Swig, GIWS, and libffi. They're all kind of used to bridge interpreted languages between native languages. GNI is specific to Java, but Swig, for instance, can be used to bridge all sorts of languages between each other. But the concept is kind of similar with most of them. The only difference, for example, in the GNA already provides you the little bit of glue code that dynamically calls everything for you, and you don't have to implement it yourself. So coming back to our memory management question, does anybody want to answer? Come on, be brave, be brave. Anybody? No?
It depends.
There we go. What is your answer?
It depends. Depends on what you use it for. If it's a C structure, it will not be.
Pretty much. You're hired. So in general, you want to free all of your mallocs. If you use malloc, free will have to come with it. However, if you instantiate a new Java object inside C, and you either use a local or a weak global reference and pass that to Java, then with time, Java will garbage collect it for you. And that's pretty much the end of the presentation. Do you guys have, so how are we doing with time? It's not too bad, actually finished much faster than I thought. I guess I should have gone a bit slower. Does anybody have any questions? Go ahead.
At the very first debug step, you printed out the PID.
Oh, I just use it.
How do you connect them? I mean, how do you, is it some script code or?
I just use a bit of Java to get that. So in SWT, we often run into bugs. In SWT, when somebody submits a bug, like something like a color issue, quite often, this is the Java part, and we have some C part of our own, but we also use libraries. So it's sometimes not clear, is the issue in our Java code, is it in a little bit of glue code that we wrote ourselves? So for example, we extended a GTK container called a fixed container to do the layouting, because GTK did not provide one. So it's not clear whether the issue is in Java, in our custom code, or in the library. So we end up kind of doing a lot of C debugging in SWT. So we kind of like end up going back and forth. Just to give you an idea how it looks, how our glue code looks. This is our glue code. Roughly, this is how it looks like. Just a bunch of function wrappers, really. And this is where we load the native parts of the operating system libraries inside Java. Any other questions? Questions? No, I think we're good. Okay, if you have anything else, you're welcome to come up. Otherwise, thank you everyone for coming, and I hope to see you again next year.